Let's consider the following two-step reaction. For A, how many bonds are broken and formed in step 1, and would we predict the delta H to be positive or negative? So let's outline step 1. So step 1, we're going to react this with HCl, and we're going to produce cyclohexane, H with a plus, and Cl minus. So we've got this reacting here, and this going over here. So we can see that two bonds are broken. We're breaking the double bond and the HCl bond, and one bond is formed as we're forming or the hydrogen from the HCl is joined onto the cyclohexane ring. So bond breaking requires energy. Therefore, the delta H naught should be positive. It should be endothermic. For B, let's look at step 2 and see how many bonds are breaking and how many bonds are formed, and whether the delta H is going to be positive or negative. Let's first outline step 2. So here's step 2, and we're going to have the Cl come in here. So we have no bonds broken. We have one bond that is formed. So bond formation, so there's no bonds breaking, so bond formation results in the release of energy. Therefore, the delta H naught for step 2 should be negative. It should be an exothermic process. For C, which step is rate determining? So bond breaking requires more energy, and this is step 1. So this would be the slow step, or the rate determining step. For D, let's draw the structure of the transition state for both steps. So the transition state for step 1 would be this carbon ring, H to H, got some dashed lines for the bonds that are going to be breaking and forming. We have H here, partial positive charge, and a bond here, Cl, and this would be a partial negative charge. This would be our transition state for plus there. That would be our transition state for step 1, and then our transition state for step 2 would be our ring, the H, dashed line H there, and slightly negative, slightly positive. H would have slightly positive on that carbon there. So here's our transition state for step 2. And for E, if the delta H overall is negative, so delta H not overall is negative, less than 0, that means this is the overall process is exothermic. We know step 1 is the rate determining step, or the slow step. Let's draw an energy diagram summarizing all of our information. So we'd have our energy on the y-axis, reaction progress on the x-axis, and we'd have our reactants, products, exothermic, so this would be our delta H naught overall. Step 1 would require the most energy. Two-step mechanism would look something like this here. And if we look at this here, draw a dotted line across here, this would be the delta H naught for step 1, and this value here would be our delta H naught for step 2.